Alright, so this is take two, Kindle. I've done this once before, um, but it, for some reason, uh, the audio software I'm using broke. So I'm gonna go through this again. Uh, you had asked me for some help on this question number 47, and I just wanted to show you my process on how I do things when it comes to word problems and how I set it up. So I'm going to use Paint and just draw out our question here, and hopefully it'll be of some help. So let's first read the question. It says a Major League Baseball diamond is actually a square, 90 feet on a side. So let's draw that first. I'm going to draw a square. And it said it was 90 feet on a side. So square has equal lengths, right? So we're gonna just write that in, 90 feet. 90 feet. That was a little far. 90 feet and 90 feet. Alright. So let's go back to the question. The pitching rubber is located 60.5 feet from home plate. So we'll say this is home, and we'll say this is 60.5 feet. So let's label that 60.5 feet. We're going to label this here home. Here we go. So the pitching rubber is located 60.5 feet from home plate on a line joining home plate and second base. The question asks, how far is it from the pitching rubber to first base? So we need to figure out from the pitching rubber, which is here, to first base, which is here. And let's label first. We want to keep everything in line here. This is first. And we're going to draw our line here up. Sorry about that. Try to keep it as straight as possible so you can at least kind of tell that it may have been a triangle. Alright, so we got to figure out what this is. But there's an issue. We can't figure it out yet because we don't know any of these angles, and it's not a right triangle, so we can't use the Pythagorean theorem. So we have to find other angles which may lead to the discovery of these different angles. And the first angle that pops out to me is the right triangle here. Right here. This right triangle. And a right triangle is, of course, 90 degrees. So what we need to first find is the length of this side. We only have 60.5 feet, but we need to figure out the whole length. So we need to figure out, we'll draw this out here. So we need to figure out what this is. And like I stated previously, the Pythagorean theorem is what we can use because this is a right triangle, and we do have 90 feet here and 90 feet here. So we have two sides, and the Pythagorean states a squared plus b squared is equal to c squared. So we're going to use that to our advantage here. That was from the previous one, right? Here we go. So a squared, sorry, it's little a because it's a side. A squared is equal to a squared plus b squared is equal to c and squared. So 90 feet. 90 feet here squared plus the b, which is 90 feet again, which is equal to the c. Sorry, fat finger that. Which is equal to the c squared. So we're just going to use basic algebra. Let me bring up my calculator. 90 squared, which is 8100. And we have another 8100 here because it's the same number, and it's equal to the c squared. So add the 8100s together. So we can just say 8100 times 2 because they're the same number. And it gives us 16,200, which is equal to the c squared. But we're not trying to find c squared, we're trying to find c. So we need to square root both sides. So the square root of 16,200 is going to be this big number here. I'm just going to copy that because I really don't want to type it out. And this root of c squared is just c. So we found our c. So our whole side here is going to be 127 point, and I'm going to round it off to the first decimal as they did on the given. And here we go. We're going to say c is going to equal to 127.3 feet. Don't forget to keep your unit right. Those will get you. And now that we've figured that out, using the Pythagorean theorem, we can now find what our angle is. And what we're going to do is use the law of sines. And I'm going to go back to over here. And we're given a side, and angle. And the angle is not between the two sides that are given, so we have to use side angle and not side angle side. So just keep that in mind. So I'm going to look up side angle trigonometry, and I go to the mathisfun.com, and it really helps with give examples and things like that. So as I stated before, side angle is when we know two sides, an angle that is not the angle between the sides. And they're going to be using the law of sines, and I'm going to click on it so you can see what I'm talking about. So sine A over sine of A is equal to B of sine of B is equal to C sine of C, and this is used to find an unknown angle. So we can use them interchangeably. We can use the transitive property C of A over A is equal to C of C over C, and vice versa. So we can use what we want and choose. So let's go back. I just wanted to show you what that was. And let's set up our picture just how they have. So we're going to use the uppercase letters to distinguish angles, and the lowercase letters to distinguish sides. So let's set it up. So let's go with angle B, which is our known one. So we're going to label this B, and the side opposite is lowercase b. So our B is this. A, which will be home plate here, and the side opposite, the angle opposite of it, will be lowercase a, and then big C will be up here, and this down here will be little c. So now we have our labels, and we're trying to find is this angle right here. Okay, so let's set it up. So we're trying to find. Let's write out what we have. So angle B is equal to 90 degrees. Lowercase e, which is the side, is equal to 127.3 feet. And C is equal to 90 feet. Now that we have our problem set up like this, we're going to solve, we're going to get our degree for A. So let's set it up how they have. So the sine of uppercase A over lowercase a is equal to the sine of our B angle, which is 90 degrees, divided by the lowercase b, which is 127.3. And I mistakenly put the C here. I need to put A because we need to remove this side, and we're trying to solve for angle A. So let me fix this error here. 90. Alright. So let's get sine of A on its own side. So let's multiply both sides by 90. So we'll have sine of A multiplied, cancel out the 90 on the left side, and now we have sine of 90 divided by 127.3, and we're going to multiply this by both sides by 90, right? So we have the 90 outside of our original problem there, or our original problem on the right side. And now we can use algebra to calculate our answer. So let's use the sine of 90, which is 1, divided by 127.3, which gives us 0.0078, and we're going to multiply it by 90, which is this number. I'm just going to copy it. So the sine of A is equal to this big number here. And what I'm going to do is calculate the arc sine. We're just trying to find A, right? So we need to get rid of sine on the left side, so we have to divide both sides by sine. And so we're going to get the arc sine of this number. So A is going to equal, and I'm going to make sure that I do this right here. So the inverse of sine, which will be the 44.9 degrees. And that was calculated using arc sine. Don't forget. So our angle, 44.9 degrees. Let's just put that into our problem here. 44.9 degrees. Stretch this out a little bit. That's what our angle A is. Alright. Now that we have this angle, we can move on to our original problem. So we're going to be using side angle side now. Previously we were using side angle, but since we have side angle side, then we can now determine what the length of this side is. So let's go ahead and use the law of cosine now. So let's go back and go side angle side trig. And again, math is fun. We're going to go to this website and show us the formula for doing this. Again, you see how they labeled all the things, their angles and sides, and we're just going to follow that procedure because I like to keep everything intact. everything organized. So we have the angle A. Let me stretch this out a little bit. Angle A is equal to 44.9 degrees. The side of B is equal to 60.5 feet. And we've gone down to we've moved on from this big triangle here to this little triangle here, because the only reason we went through the Pythagorean theorem and the law of sine was to calculate the degrees for A, that we can use the side angle law to determine what this how many feet it is from the pitcher's plate to first. So let's continue on. I just wanted to make sure that we stay on track and that you know how what we're doing. So we figured out 44.9 degrees is the angle, B is 60.5 feet, and C is equal to 90 feet. All right. Let's figure out, plug our numbers into the equation and see what we get. And this is the formula they used, and so that is the formula that we are going to use as well. Let's go back to Notepad here, and it's not A2, it's A squared 2, B squared, C squared, sorry, not A squared 2, but A squared. And this is the only 2 that's in here. And let me just type in law of cosines so we know what we're doing here. So let's bring up what we have. So we don't know what A squared is still. That's what we're going to try to figure out. But we do know what B is, 60.5 squared. And we know what C is, which is 90 squared, minus 2 times 60.5. And we'll multiply that by 90 and multiply that by the cosine of 44.9 degrees. Let's just use algebra and simple addition and subtraction to calculate what A squared is. So 60.5 squared is going to be this number. So A squared is equal to 3660.25 plus whatever 90 squared is, which is going to be 8100, minus the 2. Remember to do the order of operations here, parentheses first, 60.5 times 90. And this is going to equal to 5445. And let's get the cosine of 44.9 degrees. We're going to copy this number. Alright, let's just keep breaking our equation down. So we have 3660.25 plus 8100, and that's going to equal this number. I'm going to copy this, paste it there, minus the 2, and then we're going to multiply the 5445 times our cosine here, and I'm going to grab this number here because I don't want to retype the whole thing. So we're going to say 5445 and multiply that by the number here. And what I'm going to do is I'm going to get to the second decimal place, since that's what we have over here. So we have 2 times the 3856.91, and then we're going to keep breaking it down. 11760.25 minus, and we're going to multiply this number by 2, which gives us 7,713.82. Alright, let's subtract the 11760.25 minus the 7713.82, which will give us our answer of 4046.43. But we're trying to solve for a, right? So we need to get the square root of a squared to get rid of that squared. So the square root of a squared is equal to the square root of 4046.43, and its a will now equal to our side. So the 4046.43, we're going to square root that, and it's going to give us our side, which is 63.61 feet, because that's what we're trying to get. So we now know that A, which is this side, is going to equal to 63.61 feet. And that's how we determine the the answer for problem A. How far is it from the pitching rubber to first base? And I got to 63.61. Your answer was 63.7, but since I didn't go as far as I could with the decimal place, I got this number, but it's very close, and it should be fine. But the important thing is to really understand how the problem is set up, and how to use the laws when we have the problem set up to get this answer. So I hope this has been helpful to you. I will continue to do problems B and C. I'm just going to take a little break real quick and post this to YouTube so that I can view it. Alright, well, that's it for this video.